Hey everyone, in today's video we are diving deep into the world of Zero Trust security. We'll explore how to implement this powerful model using Cloudflare suite of tools. We'll start by breaking down the Zero Trust concept. It's a security model that challenges the traditional trust but verify approach. Instead, it assumes that no user or device is inherently trustworthy. We'll discuss the limitations of traditional security models and how Zero Trust addresses those shortcomings. By implementing Zero Trust, you can significantly enhance your organization's security posture and protect your sensitive data. In the second half of the video, we'll roll up our sleeves and get practical. We'll walk you through a step-by-step guide on how to set up Zero Trust using Cloudflare tools. Even if you are working with limited resources, you can secure your company like a seasoned enterprise. So, whether you are a security professional or just starting your cybersecurity journey, this video is for you. Let's get started. Let's start with the demonstration. Here's the scenario. We have 4 employees working from home. 2 are developers, Dev1 and Dev2, and 2 are from the finance team, Fin1 and Fin2. Each person has their own laptop. In our office, we host 2 internal web applications on servers located in a small server room. Developers use a developer application, while the finance team uses a finance application. Now, let's see how this works in practice. Dev1 starts their workday and needs to access the developer application. They open browser and enter the application's IP address. Naturally, it doesn't work. Dev1 is at home while the application is hosted on a server in the office. To solve this, Dev1 activates their VPN connection, granting access to the corporate network. Success! The application is now working. In your setup, you may not be using the same tools. Perhaps you are using WireGuard, OpenVPN, or a paid solution like AnyConnect or Global Protect. You probably access the applications via DNS instead of IP address, and you might need to log in with credentials. Still, the workflow is likely familiar. Connect to VPN and then access your internal applications. Now let's continue. While connected to the VPN, Dev1 decides to check out the finance application. And guess what? It works. Since Dev1 is on the internal network, he's implicitly considered trustworthy. Be honest, have you ever encountered a similar situation? Once connected to the internal network, you discover you have access to applications you weren't supposed to. Maybe you couldn't fully log in, but were still presented with a login screen. Now let's look at Fin1, one of the finance team members. Fin1 also needs to access their finance application from home. Like Dev1, Fin1 tries to connect, but it doesn't work. Again, he's not on the office network. So he activates the VPN and just like that, he's in. But here's the kicker. Fin1 can also access the developer application. At first glance, some might say, what's the problem? This seems like a perfectly fine approach. But is it really? Let's break it down. Once Dev1 and Fin1 connect to the VPN, they gain access to a wide range of resources, not just the ones they actually need. This is because the network automatically treats them as trustworthy simply because they are inside the corporate network. This concept is known as implicit trust based on location. Dev1 can access the finance application and Fin1 can access the developer application despite having no business need to do so. This is a classic example of overprivileged access where users are granted more access than their roles require. This model relies on simplistic segmentation approach, internal versus external. There's no fine-grained control to restrict access based on user's role, identity, or security context of their device. Essentially, once someone is inside the network, they are free to roam regardless of what they are or what they actually need to do. Let me show you how this scenario could work using the Zero Trust security model. First, let's switch to the Dev1 developer laptop. I will open a web browser and enter the URL dev.linuxcloudhacks.ovh. Notice that we are using a custom domain and there's no VPN connection in place. Immediately, I'm redirected to the Microsoft Entra ID login page. I will enter my individual username and password, and just like that, we are in. No VPN required, no extra hassle. It's important to highlight that Entra ID login page is separate from our developer application. This additional authentication step does not require any changes to the dev application itself. The dev application can still maintain its own authentication if necessary. Now, let's try accessing the finance application from the same laptop. I will reopen the browser and enter the finance app URL, which is hosted in our Office local server room. Again, I'm redirected to the authentication page. I will try logging in with my developer credentials. And as expected, access is denied. I don't have permissions to access the finance app. Now let's look at this from Fin1's perspective. I will switch to the Fin1 laptop, open the browser, and enter the finance app URL. Again, no VPN is involved. I will log in using Fin1's dedicated username and password. It prompts me to set up two-factor authentication. Let's skip that for now. And we are in. Next, I will attempt to access the developer application from Fin1's laptop. I will enter the URL and use the Fin1 credentials to log in. This time, I am presented with a message stating that I don't have access to the developer application. And that's the essence of Zero Trust, verifying the user's identity and enforcing strict access controls based on roles and permissions. Each user is granted access only to specific applications and resources they need, ensuring that unauthorized access is impossible. Let's take this a step further. Beyond verifying user identity, we also want to ensure that all traffic is fully encrypted to protect users from potential threats, such as those encountered on insecure networks like hotel Wi-Fi. To achieve this, I've upgraded the requirements for our development application. Now, it can only be accessed if the device is securely connected to the network. Let's test this on the Dev1 laptop. I'll try accessing the developer application as before. This time, we see the access is forbidden. Now I will enable Cloudflare Warp, which establishes a secure tunnel to the nearest Cloudflare data center. The Warp agent encrypts all outgoing traffic from the device using protocols like WireGuard or Mask, ensuring data confidentiality between the device and the Cloudflare network. Let's try accessing the application again. Success! We are redirected to the Entra ID login page. I will enter the username and password, and just like that, we are in. In this Zero Trust policy, I've specified two key requirements. 1. Only members of the development team can access the developer application. 2. The connection must be secure with traffic encrypted end-to-end. By enforcing these controls, we've significantly improved the security of our application and protected against common threats. Let's take the security to the next level. What if we want to ensure that the device being used, like the one our finance team uses, is a company-owned device, with an up-to-date operating system, active antivirus software, and this encryption enabled? Let's test this scenario using the Dev1 laptop, which is a personal device. I will first connect to the Cloudflare network, ensuring all traffic is encrypted. Now, let's try accessing the finance application. Notice what happens. There's no Zero Trust login prompt. Instead, we immediately get a permission denied error. Why? Because the laptop doesn't meet the company's security policy. Here's how it works. The Warp agent can perform various checks, such as verifying if the device is part of the company domain, checking whether a disk is encrypted, confirming that antivirus software is running, and much more. In this example, I've configured a policy to validate whether the PC is a company-owned device by checking its serial number. Even though we are securely connected to the Cloudflare network, the device is still denied access because its serial number doesn't match the company records. Now let's switch to Fin1 laptop, which is a company-owned device and complies with all security policies. First, I will connect to the network. Next, I will open the browser and access the finance application. After providing the Fin1 username and password, we are in. This demonstrates how we can enforce granular access policies in Zero Trust model. These policies can be based on the operating system version, specific application running on the host, the presence of a specific file on the device location, for example country or source IP, and more. With these policies, we ensure that only authorized users on compliant devices can access sensitive resources, further strengthening our security posture. Let's talk about one more feature, Warp Session Identity. First, I will connect to Warp Client. Now let's open the browser and try accessing our developer application. Notice this little pop-up. It's prompting us to re-authenticate. I'll enter the dev1 username and password. Once authenticated, we now have a warp session identity. This session allows us to authenticate to resources without needing to repeatedly enter our username and password. To demonstrate, I will reopen the browser and access the developer application again. And just like that, we are in. Since our warp session is still active and the application is configured to accept authentication via warp session, access was granted seamlessly without requiring additional credentials. Let's summarize what we learned so far. The Zero Trust security model is built on several key principles. No implicit trust. Unlike traditional models that trust everyone on the internal network, Zero Trust evaluates every access request based on multiple factors: user identity, device security posture, location, and other contextual information. Least privilege access. Users and devices are granted only the minimum access needed to perform their tasks. No more, no less. For example, in our scenario, a developer can access development tools but is restricted from accessing financial systems. Microsegmentation. The network is divided into small secure zones. If a breach occurs, it's contained within the segment, preventing it from spreading across the entire network. Fine-grained access controls. Zero Trust enforces strict access policies at multiple levels: application, user, and device. This ensures that only authorized users and compliant devices can access specific resources. Comprehensive visibility and monitoring. Every access request, whether internal or external, is logged and monitored. Centralized monitoring provides full visibility, making it easier to detect and respond to suspicious activity. Replacing VPN with identity-based access. Instead of relying on traditional VPNs, Zero Trust uses identity-based access policies. These policies ensure secure access without the need for broad, implicit trust provided by a VPN connection. In essence, Zero Trust shifts the focus from trusting networks to continuously verifying users, devices, and their context, creating a stronger and more adaptive security posture. So how does Zero Trust actually work? Let's break it down into its key components. Identity provider, IDP. At the core of the Zero Trust model is an identity provider. This is a critical component responsible for authenticating users and devices using strong methods like multi-factor authentication. It ensures that only legitimate users and devices can access resources. Cloudflare supports major identity providers such as Microsoft Azure, Google Workspace, Okta, and others. Cloudflare Warp Agent. The Warp Agent is a lightweight application installed on client devices. It acts as a gateway between the device and Cloudflare's global network. It establishes an encrypted tunnel to the nearest Cloudflare data center, routing all traffic through Cloudflare's network. In many cases, it replaces the need for a traditional VPN. Cloudflare Gateway. Cloudflare Gateway is a secure web gateway that gives you granular control over network traffic. It enables you to set up policies to inspect and filter DNS, network, HTTP, and egress traffic. If you are interested, I've created a video explaining how to set it up. Cloudflare Access. Cloudflare Access enforces granular access policies based on user identity, device posture, and network location. It integrates seamlessly with identity providers to authenticate users and devices before granting access to applications or resources. Cloudflare D. Cloudflare D is used to establish secure outbound-only tunnels from your organization's private network or internal servers to Cloudflare's global edge network. This eliminates the need to open inbound firewall port or expose applications to the public internet. I have a dedicated video explaining how to configure Cloudflare D if you like to learn more. These are the primary components we'll use in this demonstration, though there are additional components available in Cloudflare Zero Trust Suite. To set it up, here's what you'll need. A domain. I've covered how to configure one in another video. Registration with Cloudflare Zero Trust. I also have a video showing how to do this. Registration with Microsoft Azure. You'll need this for identity management. Once these prerequisites are ready, we can start piecing everything together to build a secure Zero Trust environment. Let's start by integrating Microsoft Entra ID as an identity provider for our Cloudflare Zero Trust setup. For Microsoft Entra ID, I'm using the free version of Azure. To configure Azure AD as the identity provider in Cloudflare Zero Trust, follow these steps. First is setting up the login method in Cloudflare. I will navigate to Zero Trust Settings section in the Cloudflare dashboard. Then I will go to Authentication and select Add a new login method. Then for the identity provider, I will choose Azure AD. Next step is creating an Azure AD application. In the Azure portal, I will go to Enterprise Applications and select Create a new application. Then I will click Create your own application. Then I will choose Register an application to integrate with Entra ID. I will name the application Cloudflare and click Create. Next step is configuring the redirect URI. I will go to Cloudflare Zero Trust console and copy the redirect URI provided by the Azure AD configuration. Back in Azure, I will set the application type to Web and paste the redirect URI. Then I will add our Cloudflare team name found under Zero Trust Settings, Custom Pages to complete this step. Then I will click Register. Next step is providing application details in Cloudflare. I will go to App Registrations and then All Applications in the Azure portal and select our newly created app. Then I will copy the application client ID and paste it in the Zero Trust console. Then directory tenant ID from Azure. Then paste that details into Cloudflare Zero Trust. Next, we need to generate an application secret. In Azure, I will go to Certificates and Secrets and create a new client secret. I will confirm the secret validity, that's 6 months, and click Add. Then I will copy the secret value and paste it into the Cloudflare Zero Trust console. Next, we need to enable group support. In Cloudflare, I will enable the Support Groups option. This allows Cloudflare to verify which security group a user belongs to. Then we need to grant API permissions. In Azure, I will navigate to API permissions and click Add a permission. I will select Microsoft Graph and choose Delegated Permissions. I will add the following permissions: email, offline access, OpenID, profile, user read, this is often added by default, directory read all, and group member read all. Then I will click Add Permissions. For permissions that require admin consent, I will click Grant Admin Consent. Now let me save and test the integration. To do that, I will return to Cloudflare Zero Trust console and click Save to finalize the configuration. To test the integration, I will click Test. Since I'm already logged into the Azure portal, I'm not prompted for the password and immediately see a confirmation message indicating successful integration. In my directory, I have two groups: Dev, which holds my developers, and Fin, which holds my financial folks. It's always a best practice to use groups instead of individual users when setting up permissions. It's easier to manage and scale. Let me show you what this looks like. If I go to Dev group, you will see it contains two users, Dev1 and Dev2. Similarly, if I open the Fin group, we'll find Fin1 and Fin2. A quick note, Azure's free tier doesn't limit the number of users you can have, but it does have a fixed domain name. If you want to use a custom domain, you will need to upgrade to a paid plan. Now, let's map these Azure security groups to Cloudflare access groups. I will start with the Dev group. First, I will go to Azure portal, select the Dev group, and copy its object ID. Next, I will head to Cloudflare Zero Trust dashboard and go to Access Groups. Let's create a new group and name it Dev. To identify the members of this group, I will choose Azure Groups as the source and paste the object ID I just copied from Azure. Now let's save this configuration. I'll do the same for the Fin group. Back in the Azure portal, I will go to Fin group and copy its object ID. Then back in the Cloudflare dashboard, I will click Add a group, name it Fin, and select Azure Groups as the source. I will paste the object ID from the Fin group and save the configuration. With these steps, I now have my Azure security groups mapped to Cloudflare access groups. This setup makes managing access policies much easier. Let me explain. Now that I've mapped these groups, I can use them directly in my Zero Trust access policies. If someone joins the development team or finance team, I just need to add them to the respective group in Azure AD. There's no need to touch the Zero Trust policy. Everything is automatically in sync. Unfortunately, the free version of Azure doesn't support a system for cross-domain identity management, which means we have to create these groups mappings manually. However, if you are using one of the paid plans, you could automate this process entirely, saving even more time and effort. Now it's time to register our devices into the Zero Trust domain. Each user has their own dedicated device. Dev1, Dev2, Fin1 and Fin2. All these devices already have the Cloudflare Warp client installed, but they aren't yet part of any Zero Trust domain. So how do we add them? Let me show you. First, I will go to Settings, then Custom Pages, and copy the team name. This name will be used during the enrollment process so that devices know which Zero Trust domain to join. Now we need to set up Zero Trust enrollment policy. This policy determines who can authorize a device to join the domain. I will go to Settings, then Warp Client, and navigate to Device Enrollment Permissions. Let's add a new policy. I will name it Azure and assign it to our two Azure AD security groups, Dev and Fin. Let's save the policy. Just to clarify, any member of the Dev or Fin groups in Azure AD will now have permission to add their device to the Zero Trust domain. Next, I will configure the authentication process to streamline the experience. I will go to the Authentication tab and deselect one-time PIN identity provider, leaving only Azure AD. I will also enable instant authentication. This ensures users are taken directly to the Azure AD login screen without needing to pick any identity provider. Everything is set. Let's start enrolling devices. On the Dev1 laptop, I will open Warp Client, then I will click on the gear icon, go to Preferences, then Account, and click Login with Cloudflare Zero Trust. The first prompt asks which team to join. Let me paste the team name here. Next, I'm presented with the Azure AD login screen. Let's enter the Dev1 username and password, then click Sign In. Since Dev1 is a member of the Dev group, it has permission to enroll the device into the Zero Trust domain. Success! To confirm, I will go back to Preferences and Account. Now we can see that this device is part of the Zero Trust team. Let me connect it to Cloudflare Network. If I go to My Team, Devices, in the Zero Trust dashboard, I can see the Dev1 device listed along with its owner. Let me click on it for more details. Here we can see the device name, operating system version, MAC address, serial number, and other useful information. Let's move to Dev2 laptop. I will open Warp Client, then I will go to Preferences, Account, and click Login with Zero Trust. I will paste the team name, then I will provide the Dev2 email ID and password, then click Sign In. Success! The device is registered. Let's connect it to the Cloudflare network. Now for the Fin1 laptop. I will open the Warp Client, go to Preferences, Account, and click Login with Cloudflare Zero Trust. Then I will paste the team name. Next, I will enter the Fin1 username and password and click Sign In. The device is now connected to the Zero Trust domain. Let's establish the connection to the Cloudflare network. Finally, let's enroll Fin2 laptop. I will open the Warp Client, go to Preferences, Account, and click Login with Zero Trust. Paste the team name, enter the Fin2 username and password, then click Sign In. We are in. Let's connect the device to the Cloudflare network. If I go to the Devices tab in Zero Trust dashboard, I now see all 4 laptops registered, each assigned to its respective owner. In the Overview page, I can see that we are using 5 seats, since each new user consumes a seat. In the Users tab, I can find detailed information about each user, such as their email address and how many devices they're enrolled. If I click on a user, I can also see details about their devices, and that's it. We've successfully registered all our devices into the Zero Trust domain. Next, let's expose our internal applications via the Cloudflare network. To do that, we'll need to install a lightweight client called Cloudflare D on both of our internal servers. We have 2 Debian VMs, one hosting the developer application and the other hosting the finance application. Both applications are served using the KDE HTTP server on port 80 TCP. Let me show you how this works. If I try connecting to localhost on port 80, we get the dev application. Here's the KDE configuration I'm using. It's listening on port 80 and responds with a small HTTP page and a 200 OK status. If I connect to port 80 on the other VM, we get the finance application. Now, I will do a separate video soon on KDE because it's an amazing web server. But for now, let's focus on exposing this application through Cloudflare. To create a tunnel for the developer app, I'll go to Networks, then Tunnels, and click Add a Tunnel. I will select Cloudflare D as the tunnel type. Let's name this tunnel dev app. Then I will choose Debian 64-bit as my operating system. Next, I will copy the installation script provided by Cloudflare and run it on the DevApp server. This script will install the Cloudflare D service, which establishes a permanent connection between Cloudflare's network and my VM. As you can see, the connector status is now established, meaning the connection between Cloudflare and my server is live. Now, I will expose the developer app to the internet. I will select my domain and enter dev as the subdomain. This will be the URL that clients will use to access the application. Then I need to specify where the traffic should be directed. Since Caddy is using HTTP, I will select HTTP as the protocol and enter localhost:80 as the target. Once that's done, I will click Save Tunnel. Let's test it. I will go to dev.linuxcloudhacks.ovh in my browser, and it works. So what just happened? I connected to Cloudflare's Edge network, which then routed the traffic through the Cloudflare D tunnel to the Caddy server on my VM. On top of that, I get an SSL certificate for free. Now, I will create a tunnel for the finance app. Let me click Create a tunnel, name it FinApp, and select Debian 64-bit. Then I will copy the installation script and run it on the FinApp server. Once the script runs, I see the connector is up. Now, let's map this tunnel to the FinApp subdomain. I will select HTTP as the protocol and set localhost:80 as the target. Finally, I will click Save. Let's test it. I will go to fin.linuxcloudhacks.ovh and it works. Currently, there are no Zero Trust access policies defined. This means anyone can access this application directly without any authentication or VPN protection. Second thing is, if you host multiple applications on a single VM, you can use a single Cloudflare D tunnel and assign multiple URLs to it. This is a great way to simplify the setup if you have several apps running on the same server. And that's how we expose internal applications to the public internet using Cloudflare D and Cloudflare D tunnels. Now it's time for what everyone has been waiting for. Let's define our Zero Trust access policies. I'll go to Access, then click Add an application. There are several options here, but for now, I will select Self-Hosted Application. First, I will name the application DevApp, which is the one we'll be protecting. Then I will select the domain and enter the subdomain where the application is available. Next, I will change the identity provider to Azure AD only and skip the identity provider check window since we only have one IDP. So there's no need to display other options. You can enable warp session identity here if you like, but for now, I will leave it disabled. Now I'm presented with the policy builder. I will name the policy dev policy, set the action to allow, and specify that this policy applies to any member of the dev Azure AD group. In other words, any member of the Azure AD dev group will be able to access this application, assuming they authenticate successfully. Let's click Next, and then click Add to save the policy. Okay, everything is set. Now let's test it. I will try to open the DevApp application in my web browser and I'm immediately redirected to the Azure AD login screen. This means our Zero Trust policy is working as expected. Next, let's protect the financial application. I will click Add an application again, select Self-Hosted and name this one FinApp. Then I'll provide the domain name and scroll down to the identity provider section. Here I will select Azure AD only and disable one-time PIN option. Now I will add the policy for the Fin group. I will name the policy Fin policy and select the Fin Azure AD group for this policy. Finally, I will click Next and then click Add to save the policy. That's it. The financial application is now protected with a Zero Trust policy. Now, if we want to enforce a secure connection using Cloudflare Warp on the client side, we need to configure this in the Zero Trust settings. First, I will go to Settings, then Warp Client, and click Add a Warp Client check. Here we can specify what we want to check for on the user's device. For now, I will simply select Warp Client. Okay, the check is added. Next, I will go to our access policies for the financial application and click Edit to adjust the configuration. In the Edit Policy section, I will add a new requirement by selecting Warp from the list and clicking Save. From now on, in order to access the financial application, the user not only needs to authenticate and be a member of the Fin group, but also must be connected via Cloudflare Warp to the network. Let me demonstrate. I will open the browser and try to access the financial application. But as you can see, access is immediately denied because the Warp client is not connected. To make this even more secure, let's implement device serial number filtering. I'll go to Devices, select the device that belongs to the Fin1 user, and copy its serial number. Then I will go to Lists and click Create Manual List. Let's name the list FinTeam, as this will hold a list of device serial numbers. I will add the Fin1 device serial number here and click Save. Next, I'll do the same for the second device, which belongs to the Fin2 user. I will copy its serial number, go to the serial number list and add it here. After saving the list, this will now contain the serial numbers for the devices that belong to the Fin1 and Fin2 users. If I go to Warp Client Device Posture Checks, we'll see that the serial number validation is now in place. Let's put this into action. I'll go to the FinApp Access Policy, click Edit, and add another requirement. This time, I will configure it so that access is only allowed if a device serial number is listed in the FinTeam list. Now, I'll go to Dev1 device, connect it to the network, and try to reach the financial application. As expected, access is denied, even though the device is connected to the network. That's because the Dev1 device serial number is not on the list. Just a quick note. For the serial number verification to work, you need to disable captive portal detection in the Warp client profile. So there you have it. By leveraging Cloudflare Zero Trust security model, you can significantly enhance your organization's security posture. Remember, Zero Trust is not just about technology, it's a mindset shift. By prioritizing continuous verification and least privilege access, you can protect your sensitive data and applications from potential threats. If you have any questions or want to dive deeper into specific topics, feel free to leave a comment below. Don't forget to like, share and subscribe for more tech tutorials and cybersecurity insights. Thanks for watching and stay secure.